Hi, today I'm going to show you how to take your real DNA data and quickly and safely use AI to create your Leeds Method chart. I'll also show you a real-world example of how and when to consolidate or combine your color clusters, plus why clusters sometimes merge and how you can separate them. Stick around until the end and I'll show you how to take this AI-generated chart and turn it into a clean and professional-looking spreadsheet with useful clusters that you can use for your next steps. Let's get started. Now for today's example, we're going to be using my DNA matches, and I do have the privacy mode turned on. I use Goldie May to privatize things, and so it's only showing the last names of my DNA matches to keep them private. And first thing we're going to do is filter and show only those matches between 90 and 400 centimorgans, because that's what we do with the Leeds method. So I went to that filter and then the shared matches, and I'm typing in 90 to 400 and apply filters. And now we'll only see those matches between 90 and 400. And it will show us multiple pages. We have 20 people per page. I can change it to 50. I know I have less than 50 matches, and so this should work. If you have more than 50 matches, you would just scroll through those additional pages. And now I've got all my matches here. If we go to the bottom, you can see my last one's 93, and so I was expecting it to be around 90. Let's scroll to the top. Now I'm going to hold down my left mouse button and scroll down and capture all this, and I'm going to say Control C to copy, or Command C if you're on Mac. And now I'm going to go to ChatGPT to enter this information. I want it to be in a private mode. I'm going to switch it to a temporary chat. And a temporary chat says right here, this chat won't appear in history, use or create memories, or be used to train our models. And that's what I want. That's what's safe for this semi-private information. And another way you can tell you're in a temporary chat mode is this black bar. And if you hear noises, those are my kittens over there playing. They're having fun. Let's start this. Create a table with 2 columns. One is match name. 2 is number of centimorgans of DNA. For example, and then I'm going to grab the first 3, and this is called few shot prompting. In this type of prompting, we're going to give it a few examples. So I'm going to say D shares 350. For example, D 350, and then 2 more. J is 344, J 344, and Bowker 333, Bowker 333. Now, one thing that might be problematic about this is it can probably still see the full names, and I'm probably going to have to blur it, and I'm not sure this D and J will work, but let's try it. I'm going to do Control V, and that adds everything to the table. And then we're going to have this chart. So it did figure out the D, the J, the Bowker. And it's doing it on this privacy mode, which it wasn't earlier today. I've been at this for a while today, a couple hours. So we're getting all those matches. And now we have them. Now we've got one little problem, that several of the names are just an initial, and we might have duplicates. I'm going to ask, do we have any duplicate names, initials? Because that could be problematic as I'm telling it what to do. Peters. Okay, so we've got some F's, J's, S's. And so I'm going to pause this and get some better names for these people so it doesn't get confused. Okay, I fixed those names, and you shouldn't have this problem unless there's some initials. Maybe you have 2 people named JB. You might want to fix that somehow. But mainly it's because I'm on this privacy mode and not trying to give people's real names away or their usernames. And so I fixed this, and now we're ready to take this. I prefer Claude. I think Claude and its artifacts, which is when it has that split screen, is the best for now. And I'm going to use that. And I'm also not going to quite use all of these matches just because so we can see more on the screen, and I think I'll take that many. And I've opened up a new Claude. This is just that Claude with that e.ai, and I'm going to paste this here, and I'm going to say recreate this table. And I gave it the information, and it should be able to very quickly do that. And it didn't do it as an artifact. Yes, it is. Okay, it's doing it as an artifact, which is when it's on the right-hand side. And still, I could chop a few more people out, but I think I'll just leave it like this. Now I've opened up these two screens side by side, and this makes it a little hard to work with. I'm used to working one screen, and then I've got another screen over here, but I want you to see what I'm doing. So I've changed this D to Dawn, and I want to see Dawn's shared matches. So with the Leeds method, we work with the top person, and we look at all their shared matches, and they all get the same color. Now, if you don't know anything about your matches, that's where you start. But if you do know something about your matches, you don't want to use a first cousin that shares two of your grandparents with you. For example, you wouldn't want a first cousin once or twice removed, like your first cousin's children or grandchildren, because they share two grandparents with you, and that would be grabbing the whole paternal side or whole maternal side. And so I would check that on the key people, the people I use to start each cluster, like I'm using Don. Now I know who Don is, and he is not a younger first cousin once removed. And so I'm going to go ahead and use him, and I'm going to click on him and then his shared matches. So we're here, and I'm going to use the shared matches. He's actually an older first cousin once removed, and that's why I don't need to worry about him because he only shares one grandparent line with me. He's a descendant of one of my grandparents' siblings. He's a child of one of my grandparents' siblings. That makes him also a first cousin once removed, but it means he only shares one line, not two. And so now I want to find, again, those matches between 90 and 400, and I can filter them here. Filter shared DNA and type in 90 to 400 and click apply. And then we should start seeing matches that are over here, like Jay and Bowker. So at this point, I know why I did fictitious data on the first one. It is getting really hard to keep these privatized names private. And so instead on this screen, I'm going to go through what I did earlier today with my full DNA matches from 400 to 90 and show you those steps. And we're just going to have to privatize the names, kind of blur out except for the first few letters. And I'm going to have to privatize some of the chats, but hopefully keep what's important. And so I started just like I had started with you guys. I said, recreate this table with column labels of match and number of centimorgans, or just CM. And you can see it's done that. And then it's created this table. Then I gave it this next prompt. I said, now create a red column with a red dot for each of the following. And I gave these names and I told it to run. And so if you can see down here, it says version. So I did 16 versions, and I can just click to see the next version where we have the red dots. I think I'll move me over here. There we go. So we have the red dots. And then I said, we are doing the Leeds method. And let's now create a blue column for, and I gave it the name. So really this is, it's the Leeds method. So I'm looking for the highest person without a dot already, without a color, and that is Sarah. And so I'm going to create a new column. It's blue, and it's going to be for Sarah and all of her shared matches. And that will be the next version. And now we have the blue column over on the right, and we can see my new prompt on the left. It had skipped somebody, and I don't remember why at this point, but I said add a blue to that person, this W person. Then a green column for, and I said who I wanted the green column for. And we got these. And again, if you don't know how fast this is, you can look at my video, which I'll put up here, where I was doing this with fictitious data. And at that point, I didn't have to worry about trying to privatize things. I said people can be assigned more than one color, which it did correctly, but sometimes it hasn't. But if you notice, the second person, JB, is both red and green, and I was just letting it know that was okay. And then it's going to apologize, but it had done it fine. Then I said now orange, and I listed some people. I had to scroll down a bit, but now you can see there's a new column with some orange people. And then I said now yellow for, and I gave it another list. And now we have some yellow people, and I said now purple. Again, we're just scrolling down and finding the highest person without a color. And as I scrolled down, the highest person was this person here, Jim. And I wanted purple for him and his shared matches. And now we have purple for Jim and some of his shared matches. And I keep doing that. So I'm again looking for somebody who doesn't have a color. I asked it to pick its own color and I gave it a new group because I was running out of colors. It chose teal, but it gave me these little bitty diamonds that I guess are teal. But I said, change teal to black. I know the black color works. And then I said, can you privatize these names so I can share them? I said first initial, last name, initials, or shortened 4-letter usernames. So we'll be able to see things again. And it actually changed everything to initials, but this is perfect. Well, there's a few usernames that are just a few letters, but now we can actually work with this without having to keep blurring things out. My next prompt was, please analyze this table, give insights, and make suggestions. And so it did. It talks about group distribution. It tells you how many matches are in each group. It says multi-group assignments. Some of these people, like JB, so here's JB, is both red and green, or green and orange. There's quite a few people who are green and orange, like this is a different JB, or a DCGR right here. And it said we've got some that are blue and yellow, some that are blue and black, things like that. Then it said key insights, blue, yellow, black. Let's go to the top here. We've got blue, yellow, black. There's a strong connection between these three groups, with several matches appearing on all three. This suggests a complex family relationship, possibly representing a branch where multiple lines converge. Well, that's interesting. I'm not sure what they're talking about with this complex family relationship, but if you know how I do the Leeds method, I say if most of the people in one color are also in another, you can consolidate those or combine them. And that's because they probably represent the same part of your family tree. So let's look at blue, yellow, and black. Here we have a CA, blue, yellow, and black. WW. FD's only blue. Sarah is blue and yellow. FLC is blue, yellow, black. And we've got some more blue, yellow, black. And so blue, yellow, and black probably represent one part of my family tree, and I will consolidate or combine those. Next, it talks about red and purple. These groups share 4 matches, indicating a distinct family line with some unique characteristics. Again, I don't know exactly what that means, but let's look at red and purple. Here we have red and purple, just red, red and purple, red and purple. So there's a lot of red and purple, and we could count, but most of the people in purple are also in red, and I'm going to consolidate those, but it's pointing this out. And then it says green and orange. We've got green, orange, green, orange, green, orange. And so most of the people, 3 of the 4 orange people are also green. So I'm also going to ask it to consolidate those. Now you could read through the rest of these results. It talks about chromosome mapping, which on Ancestry, which is where this data is from, you can't see the chromosome browser, so we're not going to even worry about that, or DNA Painter. But really what it boiled down to is I wanted to see which ones to consolidate. And instead of asking it to analyze, I could have asked, which colors do you think we should consolidate? And that would have been probably more helpful. And so I said, let's merge the following based on overlap: blue, yellow, black, red, purple, green, orange. And I'll go down here and change to the next version. And it's consolidated, blue, yellow, black, red, purple, green, orange. And then I said, change the names of each color cluster to just one color, the one the dot actually is. And why do I have 3 clusters? I thought I should have 4. And I wasn't really asking that for me. I was asking it as an example to see how it would respond. And here it has changed to that blue, red, green. And let's see what it says. It says, you're correct that there should typically be 4 clusters in the Leeds method. And actually, that's just a best case scenario. Many people do get 4 color clusters based on their 4 grandparent lines, but not everybody. And it's definitely not wrong if you have more or less. It just means there's something else you need to figure out, and why that many clusters formed and what each cluster means. But if I get less than 4, I want to figure out if maybe 2 of them have actually been combined, and one of these groups is representing an entirely paternal or entirely maternal side. And that's often because I've grabbed a first cousin, like a younger first cousin, once or twice removed usually. I've grabbed that person as a key person, the person who I looked at to look at their shared matches and create this color cluster. And so they grabbed all of the paternal side or the maternal side. And if I skip them, we might actually get that broken into 2 pieces, and then we'd have 4 clusters. So it said the reason for 3 clusters, the Leeds method typically looks for 4 grandparent lines, but the number of clusters can vary based on your specific genetic inheritance of family history. Very true. Having 3 clusters instead of 4 could indicate endogamy, which is true, recent ancestors from multiple lines, uneven inheritance, implications and suggestions, next steps. Again, I'm going to just skip a lot of what this said. It's not always correct, and I don't really want to dig in and see exactly what it's saying. But I am telling you what I would usually do is look at those key people. And if I know how a lot of my matches are related to me or the test taker, I would look to see if some of them are actually related to 2 grandparents. Again, that's usually because they're actually a descendant of that couple and they're a younger first cousin once or twice removed. If I don't know how these matches are related, like maybe it's a unknown parentage case or unknown great grandparent or grandparent case, then I would still just maybe skip a match in each group and see if that helps, or skip 2 matches and see if that helps. So let's see what I did next. I said, I am the creator of this method. Each cluster is created by looking at the highest match who doesn't have a cluster. They are the key people, and their shared matches create the rest of the cluster. The first place I would look is at those key matches. Are they related to 2 grandparents? If so, or if unknown, try skipping them and starting with a different person. You might even try this with several different people, which is what I explained to you guys. And I told it what the key people were because it actually missed who the key people are. But I explained that Sarah, who is the 4th person, the 325 centimorgan match, she's actually a first cousin once removed. She is my cousin's child. So she's related to both of my maternal grandparents. I need to skip her and redo the blue cluster. So erase the blue cluster, I'm telling Claude. Instead, let's create a new cluster and call it gray. It will consist of Stacy, which is the one right below, the SY. It will be Stacy and her shared matches, and then I name those shared matches. And let's see what it does. So it's got these gray, but it's really just a white circle. I said, change gray to yellow. Now a purple cluster. I'm going to continue just like I'm kind of redoing part of this. Who's the highest person without a color is this person CL. And I'm going to say, now make a purple cluster with CL and their shared matches. And I list those matches. And we get this table here. Okay, we have 2 other people that don't have a color yet, Olin and Kathy. This time, instead of starting a cluster with Olin and one with Kathy, I looked at Olin's shared matches and saw what group they were showing. Like, where are all these matches? And the same with Kathy. And both of them were matching purple people. And so I said, add Olin and Kathy to purple. And there, it added Olin and Kathy. I said, now sort by color. And I love this. This is where I really wish you guys could see this live. And I just cluster it and it changes. And now I'm going to ask it to privatize these names. And so I can show you again. And here we have the names privatized. Now it's clustered. It's sorted by color. I just love this. This is a lot faster than Excel. But let's look at this chart a bit. We now have these 4 colors. And I know this again is my family, and I was able to determine these are my 4 grandparent lines. There are a couple people, JB and Sarah, that are 2 colors. Now remember, Sarah was that problem earlier on because she was a key person and she started a color cluster and she grabbed the other people. And that's why we had 3 clusters instead of 4, because she is my younger first cousin once removed. So she shares both of my maternal grandparents. And so that makes sense. She's yellow and purple. And in fact, if I look on Ancestry, hopefully it would be telling me all these yellow and purple people are maternal. Then we have somebody here, JB, who's red and green. Now he or she, I believe, would have been the key person if DM wasn't here, and we would have had the same problem. JB is a younger first cousin once removed on my dad's side, and JB shares 2 grandparents with me. My grandparents are JB's great grandparents, and so they are showing this paternal side. And before Ancestry used to show us maternal and paternal, this is how we were able to see maternal and paternal with the Leeds method. We were seeing some people show up in 2 colors. And so this is a perfect, beautiful example of a Leeds method chart showing these paternal groups here, the red and the green, and these maternal, the yellow and the purple. And that is what AI can do to help us with the Leeds method. Okay, now let's see how we take this table and move it into, I'm going to move it into Excel. Now to do that, I'm going to do my left mouse button and click and scroll, and then Control Z because I'm on Windows. And then I'm going to move over here, move myself, and I am going to get in this cell and right click. And when you hover over these, it shows you what's going to happen. And so this one looks pretty good. Now let me show you how I clean things up. I always click on this button here and I change all the borders. And I'm going to center these numbers because I like that. And now let's see if I can just take these and change these boxes to red and hit a delete to get rid of those. I can change this to green. Let's use that green. That's my favorite. And delete. And these to green. These are pretty cool little cells. Then we've got, I need to move this over so we can make that the same size as the others, and the same with this. I'm just double clicking on that bar. Whoops, and I want to go delete. And this color, I could freeze those, but I'm going to say yellow and delete. And this is purple. Delete. Purple. Let's see if I can figure out to freeze it really quick. It's not something I do often. We're going to go freeze. I'm going to be outside of your view, but I just typed freeze, and I'm going to say keep the top row. And now as I scroll, we can see that. And now we've got our Leeds method chart, and we can start putting notes here. I'm going to bold that so it looks like the others. We could say who the people actually are. We could label these, like I could say grandparent 3 and grandparent 4. Actually, I think those were, I said those were paternal. Grandparent 2. Maybe this is grandparent 4 and grandparent 3. And I actually know this is 3 and 4. Anyway, I could add my notes here. I could say who the actual common ancestor is, the MRCA. And that's how you do this part. Before I wrap things up, let me point you to 2 helpful videos. If you're new to the Leeds method and need a more basic tutorial, check out this video. Or if you've already created your Leeds method chart, but you aren't sure what to do next, check out this video. If you found this helpful, please hit that like button and subscribe to my channel. Don't forget to tap the notification bell so you'll know when I post new DNA and genealogy tips. For even more resources, check the description below where you'll find my free Leeds method guide and a link to sign up for my newsletter. Thanks for watching and happy clustering.